Hi students, today our topic of discussion is the most awaited topic of aldehydes, ketones, carboxylic acids, and that is aldol condensation. Very, very important. Let us see what it is all about. Aldol condensation. ये हम रेडी हैं aldol condensation. Now, first of all, what do we understand by condensation? Condensation is basically a process or a reaction in which two smaller molecules are joined to get a larger molecule with or without the elimination of the water molecule. Condensation reactions are those reactions in which two or more smaller molecules combine to form a larger molecule with or without the elimination of small molecules like water, ammonia, etc. Now here, aldol condensation. Why the word aldol will come somewhere during the lecture. Now, the very first thing, what are those conditions which are required for this reaction, that is aldol condensation, to happen? The very first thing is the molecule must have alpha hydrogen. Alpha hydrogen must be present. So the very first thing which is required for an aldol condensation to take place is the molecule which has to undergo aldol condensation should have an alpha hydrogen atom in it. What's an alpha hydrogen? I hope you all know. Alpha H are the H on, alpha H are the hydrogens on, alpha H are the H on alpha carbon. And I think everybody knows what's an alpha carbon. Yep. Alpha carbon is the carbon which is adjacent to the functional group. See, that means if I take an aldehyde which looks like this is the functional group. So this becomes the alpha carbon and it should have hydrogen on it. Similarly, if I take a ketone molecule which looks like this, here is the carbonyl carbon which is the functional group carbon, and on the adjacent of the functional group, that is carbon attached to the functional group, is the alpha carbon. So this is an alpha carbon, this is an alpha carbon, और अगर ये alpha carbon पे hydrogen है, खाली अल्फा कार्बन होने से कुछ नहीं होता, उसके पास हाइड्रोजन भी होना चाहिए. अगर उस अल्फा कार्बन पे हाइड्रोजन है, then the molecule will show aldol condensation. Now, to do any reaction, we need some reagent. Only substance having alpha hydrogen will not give me aldol condensation. But which reagent is required for this reaction to take place? So that's a dilute base. A dilute base like 10% caustic soda. Or we can also make use of Barita, BaOH twice. Or a base like KOH can be used. So dilute bases are required. Now, what I will do, first I am giving an example, a general example in a very simple, in a plain manner I am giving. And then once we do that example, in this lecture only, I'll go to the mechanism. Okay. So let's take a molecule having alpha hydrogen. I can take H3 here. So that'll be acetaldehyde. So here I write a molecule of acetaldehyde. Can I treat it with, we need minimum 2 molecules. I can take 2 molecules of same aldehyde having alpha H. I can take 2 molecules of different aldehyde having alpha H. I can take 2 molecules of ketone having alpha H. I can have 2 molecules of different ketones having alpha H. I can also take a substance not having alpha H, but since I know 2 molecules are required, तो अगर एक में alpha H नहीं है तो दूसरे में alpha H होना चाहिए. Meaning when I take 2 different molecules of aldehydes or ketones, or one aldehyde, one ketone, then out of the 2 different molecules, anyone should have alpha H. नहीं तो reaction नहीं होगा. So here, just it's our first example. So let it be simple. And to make it simple, let us make use of acetaldehydes, another molecule only. So I'm writing here another molecule of acetaldehyde. See, what I did is I wrote the alpha hydrogen separately. Just for convenience to understand, ये alpha carbon है, तो ये alpha H है. I just wrote it like this so that I just kept one alpha H aside because I know the entire story is based on alpha hydrogen. तो उसको पहले ही अलग रख दिया. Now we can see what is happening to that alpha hydrogen in the equation. Hydrogens are electropositive, my dear students, and this is the functional group. So obviously the electropositive hydrogen will move to the oxygen, just simple way. This is not a mechanism. I'm not doing the mechanism. Just to understand it in a very simple manner. Now we know this happens in presence of dilute base. So let me take the solution of 10% NaOH. Now we get CH3CO. This H comes here, down a H, and we will think what happens now. Now see, this alpha carbon, one valency gadbad, and this carbon also one valency gadbad. So gadbad, a new carbon-carbon bond is formed to satisfy their fourth bond. So the fourth bond of each of the carbon, that is the fourth bond of the alpha carbon of one of the aldehyde, and the fourth bond of the carbonyl carbon of another molecule of aldehyde, satisfied by making a new carbon-carbon bond. Now if this is alpha, this is beta, so I can call this molecule as beta hydroxy. You can say hydroxyl group over here, isn't it? So हम इसे बोल सकते हैं बीटा हाइड्रोक्सी और 1, 2, 3, 4 यानी कि ब्यूटारल्डिहाइड. So it is beta hydroxy N-butyraldehyde. That is the name of the molecule. Common system. I can also call it acetaldehydes. Now see, look here. This is an aldehyde group, and children, this is an alcoholic group. मिलजुल के बन गया aldol. It simply means the molecule having a molecule which is bifunctional, and in the bifunctional group, one of the group is an aldehyde and the other group is a alcohol. So the name aldehyde and alcohol. So aldehyde, alcohol. So aldol. What about the IUPAC name? This is 1, 2, 3, 4. So 3 hydroxy butanol. That is the IUPAC name. The reaction doesn't stop here. The last step involves elimination of a molecule of water from this. I just write the aldol, C, OH here, NH, CH2, C double bond O, H. This is one of the application of aldol condensation. If you heat the molecule, you know alcohol will undergo dehydration and a molecule of water is eliminated. And one H will go from here. Why from here? Why not from here? Because OH तो इधर से ही जाएगा, जहाँ है वहीं से जाएगा, but the H will go from adjacent carbon. लेकिन adjacent carbon में हमने वो कार्बन सेलेक्ट किया जिसके पास कम H है और ना कि वो कार्बन जिस पे ज़्यादा H है, because when the hydrogen is eliminated for carbon which is having less H, we are following the Sadzef's rule and more substituted alkene is becoming the major product. So we are getting CH, a double bond here, CH and C double bond OH. That's croton aldehyde or but2-in-ol. Now, what I want to see now is the mechanism part. Let us see mechanism. Students, in the mechanism, what I want to tell you all is, we will be, of course, we are writing the mechanism, but while writing the mechanism, I'll not take acetaldehyde. I'll take some other aldehyde. Let me take higher one. Let us take propanol. Okay. Now see what happens. I take a molecule of propanol. This is the molecule of propanol. This is the alpha carbon and this is the beta carbon. Now we know the reaction takes place with the dilute base, and the dilute base is actually giving us the nucleophile like this, isn't it? This is the nucleophile which we are getting, that is OH minus. These two electrons are in this negative charge. I'm just indicating that. Now students, in our lecture, one of the lecture, I think the lecture number 26 in halogen derivatives of alkanes, we learned that an anion can behave as a nucleophile as well as it can behave as a base. Let us see. If hydroxyl ion behaves as a nucleophile, suppose, I'm not saying it is a nucleophile, suppose it behaves as a nucleophile, then it will attack the electropositive carbon. सीधी बात है. A negative anion will attack the electropositive center. So it will attack the electropositive ion. Now, this is the electropositive ion and this is how it is trying to attack here. But if this OH minus is behaving as a base, suppose it behaves as a base, then students, it will try to abstract a hydrogen from here. It will try to abstract the hydrogen. Any one thing it can do. If this OH minus behaves as a nucleophile, then it will attack the carbonyl carbon, because nucleophile is a negative species which will attack the positive center of the carbonyl group, and that is the carbonyl carbon. But if this OH minus behaves as a base, then it will abstract a hydrogen from the alpha carbon. This reaction where OH minus behaves as a nucleophile gives an unstable product, a more unstable product, and hence the reaction is not feasible in that direction. The reaction which is feasible here is when OH minus behaves as a base. So this is not feasible and this is feasible. So what happens if it abstracts a proton? I'll be getting a anion. Why? Because the proton is eliminated plus H plus, and the two electrons of the CH bond are retained by the alpha carbon. So alpha carbon acquires a negative charge. This can also have a resonating structure. Let me write this over here. From here we are abstracting a proton, so minus H plus. This, okay, even if you write it here, it's fine with us. Now it can have a resonating structure. See how this can resonate like this, whereas this moving on the oxygen. So I'll be getting the resonating structure like this, carbon O minus NaH. So these are the two resonating forms. This is an enolate ion. We did it in tautomerism also. We can also call it carbon ion. This is the aldehyde carbon ion, propion aldehyde carbon ion. Now, this one is, out of this and this structure is more stable while this structure is unstable. और वो तो मेरे ख्याल से सबको आता है, कॉमन सेंस की बात है भाई. आपके पास नेगेटिव चार्ज है तो नेगेटिव विल बी मोर स्टेबल ऑन ऑक्सीजन ना. तो यहाँ नेगेटिव ऑक्सीजन पे है. Obviously, a negative charge on the oxygen is more stable because oxygen is an electronegative atom, and an electronegative atom will retain the electron pair on it easily. Whereas if you see here, the negative charge is on carbon, and we all know carbon is electropositive in nature, so carbon will not retain the negative charge properly. So negative charge will be unstable on carbon, but the negative charge will be stable on oxygen. Now this carbon ion can attack the other molecule of propanol. I'm writing another molecule of propanol like this, and I'm writing the carbon ion. I'm just making the carbon ion like this, just for convenience. It's whichever way you make, it's okay. You can make it like that also, the way it is. Now this can come here, obviously, because the carbon anion, and this is the electropositive center, while this is the electronegative center. So this can attack here, and the moment it attacks, obviously the electron pair will move to oxygen. And what I'll be getting is, see, I'm just writing, okay, this carbon, this O, this negative comes here, and now see, this a new carbon-carbon bond is formed like this, and I'm writing this, and here a C and a O and a H, and there is a H here. So this is what is formed. Now the mistake a child can do over here is, उसने अगर इतना ही ध्यान में रखा हो कि टीचर ये H को इधर लेके गए, तो what the child can do is वो भी ये वाले H को लेके चला जाएगा, but that H is beta H and not the alpha H. So whenever the carbon chain has alpha, beta, gamma carbons, you have to be very careful that the abstraction of the proton is only from the alpha H, and the carbon ion, the negative charge is on the alpha carbon and not anywhere else. So during aldol condensation, a new carbon-carbon bond is formed, and this results in the formation of an alkoxide ion. अब क्या, अब तो कुछ करना ही नहीं है. Last step में क्या होगा? Protonation. That's all. So finally the product will be simply protonation like this. See, OH, NH, and like this, and C double bond OH. And then from beta carbon OH goes, and from the alpha carbon इधर एक H भी है, the H goes. And so we get the product. करेक्ट, ये डबल बॉन्ड आ गया, इधर एक मिथाइल ग्रुप है. Let us name the molecule, students. This is propanols. So propion aldol. IUPAC name 1, 2, 3, 4, 5. And 1, 2, 2 पे मिथाइल है एक. So H पहले लिखूंगी M, hydroxy and methyl H. So 3-hydroxy, 2-methyl, 5 कार्बन है ना, पेंटानल, 1 2 3 4 5, 3-hydroxy 2-methyl हो गया ना। देखो पेंटानल में 5 और मिथाइल में 1 6 और 3 6 कार्बन है। Okay, this one 1 2 3 4 5. So 2-methyl pent, 2 in al, correct? 2-methyl pent, 2 in al, 2-methyl pent, 2 in al. और समोसे के बिना कुछ नहीं होगा, सो हीट कर दिया हमने। सो दैट्स एल्डोल कंडेंसेशन, दैट्स द मैकेनिज्म। अब देखो कौन ये रिएक्शन नहीं दे सकता, जिसके पास अल्फा हाइड्रोजन नहीं है, जैसे कि फॉर्माल्डिहाइड। Another one who cannot give this aldol condensation is benzaldehyde. So students, formaldehyde and benzaldehyde cannot give aldol condensation. So now in this video we completed with aldol condensation, a simple example, and we also completed the reactions mechanism with a pretty difficult example, that is propanol. इतना इस वीडियो में हो गया। अब नेक्स्ट वीडियो में क्या करेंगे, क्रॉस एल्डोल कंडेंसेशन देखेंगे, और उसके बाद क्लास में हम लेक्चर में एक से एक डिफिकल्ट मॉलिक्यूल का एल्डोल कंडेंसेशन देखेंगे। एंड वी विल लर्न ऑल द पास्ट क्वेश्चंस में जितना जेई में एल्डोल पे आया है, जितने क्वेश्चन नीट में आए हैं एल्डोल पे या सीईटी में आए हैं, और इन केवीपीवाई और इन आइसर, जिस भी एग्जाम में एल्डोल का जो भी आया, टफ से टफ क्वेश्चन, वेदर स्ट्रेट चेन, वेदर बॉन्ड लाइन, वेदर ब्रांच्ड, वेदर रिंग, एवरीथिंग वी विल डू। Okay, bye bye. Love and blessings to all of you. Take care, students.